Hi, good afternoon and welcome to Xiao's Sci-Café. My name is Nadia and I will be your host today. This event is brought to you by the Office of the Vice President for Research here at KAUST. So today's topic is on renewable energy, and it's quite timely with the G20 in Saudi Arabia this November. And one of the big thrusts within the Science 20 was a circular carbon economy, reducing, reusing, recycling and reusing CO2 emissions. And a great way to do that is to contribute to a circular carbon economy is by using renewable energy instead of relying so heavily on fossil fuels. So let's find out a bit more about renewable energies, how they're used and why we're not using them constantly in our lives. I'm joined today by Associate Director to KAUST Solar Centre, Professor Frédéric Laquai, Professor Volker Vahrenkamp from our Petroleum and Engineering Centre, and postdoc Dr. Xiaoyuan Zhang from KAUST Combustion Centre. I hope I didn't butcher any of your names there. So hi everybody, it's great to have you here today. So I guess we'll start off in our usual fashion and get introductions from all of you before we really dive into the renewable energies such as solar, geothermal and alternative fuels that you'll all be touching on today. Frederick, if you don't mind, I'll get you to start us off. Introduce yourself, tell us what you do at KAUST, especially with regard to renewable energy.
Sure, thanks Nadia. Hi everyone. So I joined KAUST in early 2015. Since then I've been an associate professor in the material science and engineering program and also now associated to the applied physics program. So I'm, as you've heard, a faculty also in the KAUST Solar Center, and naturally as faculty in the KAUST Solar Center, I'm interested in renewable energy generation. So just to be a bit more broad, in the KAUST Solar Center, we actually look at a lot of different types of solar energy conversion, and one is of course photovoltaic energy conversion. So we develop new technologies for renewable energy conversion, and we also try to advance already existing technologies. Now, my specific focus is what is called light matter interaction. So I'm interested in what happens between the photon absorption and the charge carrier generation, so the current that you get out from your solar cells. And we investigate those processes by what is called laser spectroscopy. So basically, we can follow how charges are generated, how they disappear. So we do that in order to understand the loss processes in solar cells and why efficiencies are lower than what theoretically is expected for certain materials. Now, there's a lot of interesting physics going on in these solar cells. So my aim is to try to understand those physics and to develop what is called structure property relationships so that we can predict materials that at the end give us higher solar cell efficiencies.
Brilliant. Thank you, Frederick. Okay, there was a lot of information there, so we will definitely talk more about solar energies in a bit. Volker, I'll go to you next. So please do introduce yourself. Tell us what you do at KAUST, and especially with regard to renewable energies.
Yes, hello. So my name is Volker Vahrenkamp, as Nadia said already, and I'm a professor in the Ali Naemi Petroleum Engineering Research Center and the Energy Research and Petroleum Engineering Program. And so I'm a geologist. Yeah. So before I came to KAUST, which is about 4 years ago, I worked for many years extracting energy from the earth, but it was oil and gas, right? So I come from the oil industry really. And one of the issues that we ran into when we were drilling and producing the hydrocarbons was that it was hot down there in the earth where we were drilling into, right? So we were struggling to deal with temperatures above 100 degrees, and that was a big nuisance. So when I left the oil industry and came to KAUST, we started thinking, can't we do anything with this energy? And so I started thinking about geothermal energy, and that is one of the research that we're doing in our research center. And yeah, I'll leave it with that.
Excellent. Thank you, Volker. Very interesting. I can't wait to hear more about geothermal energy. Xiaoyuan, over to you. Please introduce yourself. Tell us what it is you do at KAUST, and especially with regard to renewable energies.
Thanks for your introduction, Nadia. Hello, everyone. My name is Xiaoyuan Zhang from a Clean Combustion Research Center. My research is mainly focused on combustion chemistry of various fuels, including both fossil fuels and promising renewable fuels. Combustion can provide us light and heat, just like a candle flame. Then I have a question. Why the candle flame color is yellow? To answer this question, we need to use combustion chemistry studies to find out what happens inside a candle flame. We can measure the intermediates and the products generated in a candle flame, and we can find that actually there are a large number of intermediates produced in this flame. Among them, soot particles can be produced around the flame core, and the yellow light of a candle flame actually comes from the radiation of these soot particles. From these combustion chemistry studies, we can also know how a certain fuel is converted to this kind of soot particles. Actually, they go through thousands of reaction steps, but combustion chemistry can help us to identify which are the controlling reaction pathways and help us to control them, control the combustion process. And the combustion chemistry can also help us to predict how much heat is produced and how much emissions are generated. For today's topic, I'd like to talk about the utilization of alternative or renewable fuels through combustion. Renewable fuels are served as a chemical way to storing the renewable energies. Their energy can be released through combustion. Compared with the traditional fossil fuels, renewable fuels they have their special physical and chemical properties. So the question is, what are the advantages and the challenges by using these renewable fuels, and how can we improve the efficiency and reduce the pollutant emissions when burning renewable fuels? These kind of issues are my current interests. Thanks.
Thank you, Xiaoyuan. Excellent. And I just want to add that you're our only postdoc on this panel today, so the others are professors. You're fantastic. So, okay, guys, what are the real-world applications for your research in renewable energy? Xiaoyuan, I'm just going to ask you to put yourself on mute. Frederick, like the average person might think, you know, why aren't there solar panels plastered to every building in the world, especially in a country like Saudi Arabia, where sun is so plentiful? Can you tell us a little bit more?
Yeah, that's a very good question, and I think everybody knows silicon solar cells. So I just have an example here. This is what you all have seen probably before. Yeah, a silicon solar cell, which you find in a typical silicon PV module. Okay, so there's not much wrong with silicon. Yeah, it's very efficient material. It's a robust material. It's stable under light illumination. But you see that silicon typically comes in one color. Yeah, so it's this bluish, shiny, sometimes black cells that you have. So now, well, coming back to your question, why don't we put it just everywhere? Well, I mean, there are certain areas where you don't basically want to have such a color, for example. Yeah, if you talk about architectural challenges, so for example, yeah, where do you really want to have that on the walls of your building, for example? What about integration into windows? Yeah, you wouldn't certainly want to integrate it into a window because you want your window still to be transparent. Another issue is if you think about other applications, silicon is quite heavy. The modules are rigid. Silicon itself is quite brittle. And again, it comes just as one color. So silicon is very nice technology, but there are other technologies that not necessarily compete with silicon, but that can actually fill gaps. For example, when you talk about flexible devices, or when you talk about mobile applications, then what we can use is, as an example, organic materials, so-called polymers or plastic materials. Everybody, I guess, knows plastics, and everybody knows that those plastic materials, they are flexible, for example. And there are many different organic materials. So in principle, you have much more tunability of color, for example, of the properties of your solar cell. So you can have transparent solar cell. I have an example here. This is an organic, so-called organic solar cell, so a plastic solar cell. So you can see that it's flexible. Yeah, you can bend it. With that, you can have very different applications. One application that I can very quickly show you is this one here. So you could, in principle, integrate your solar cell into a bag that you can carry around. And the bag then, of course, comes with a cable and a USB connector. So you could put it in the sun and just charge your mobile phone. Now, this is one of the examples, well, of application of organic solar cells. So now, why don't we use just organic solar cells? Well, there are also, of course, problems with organic solar cells. So first of all, the efficiencies are not as high as silicon. And very often these efficiencies are only demonstrated on very, very small demonstrators that we make in our labs. Of course, for application, you want something which is much more large scale. So you have to demonstrate these efficiencies also on a larger scale. Then when you think about organic materials, and I guess everybody knows plastics, when you put plastics in sunlight, well, at some point they might just decompose. And that is a big issue. Yeah, you want stable materials. You don't want to throw away your solar cell after a year. So you need to somehow make stable materials. And many of the materials that we currently have, they are still quite costly. So reducing the cost of those materials is also an issue. Now back to the research that we do at the KAUST Solar Center. Organic materials, and as I've mentioned, there are so many different materials that you could in principle combine to make an organic PV device. They come with a lot of different properties, physical properties. So our aim is to understand those physical properties in order to design new materials that could potentially be more efficient. This is one of the aims that we have in the solar center. So we try to develop what is called structure-property relations to reduce the complexity of those materials.
Excellent, thank you. Okay, so it's just not as straightforward as I thought it would be. Yes, we have a massive big sun, but we need to ensure that we have the right solar cells for the climate to be placed there. And then I think we'll move on to challenges in a bit, but I think we should definitely talk about, you know, the storage of solar cells after this. And once we even do install solar cells, you know, how much can they store, how much energy can they store, and how long can they last? But we'll go on to that in a bit later. Volker, where are we with geothermal energy? This one's new to me. I don't know too much about geothermal energy, so please do enlighten us. What are the real world applications for geothermal energy?
Okay, well, right. So, you know, actually geothermal is probably the little sister of solar and wind energy if you look at renewables around the earth, right? So it is, you know, it is applied almost in many places, but it doesn't deliver all that much renewable energy yet. What is behind geothermal is that the earth is hot, right? So behind me here, there is the, you know, my finger is getting really hot because in the center of the earth, we have about 6,000 degrees Celsius. So it's super hot from radioactive decay. And this heat is basically radiating outwards towards the crust and towards the outside of our earth. So, you know, and geothermal is trying to harvest this energy. And the good thing about it is there 24 hours a day, 365 days a year, so that it doesn't rely on the sun shining, it doesn't rely on wind blowing, or so it can be used as a baseload energy. So that is really fantastic. And it's one of the things that we're trying to harvest this kind of energy. So what could we be doing with this, right? So, you know, we could, for example, heat our houses. I'm right now still stuck in Germany, and I recently had a guy coming to my house who checked whether he can install geothermal heating and to heat my house here. And that would be a very nice application. We are thinking about desalination and all kinds of other electricity. So yeah, that is some of the applications that we're aiming at. And the problem is then though, okay, so how do we harvest this heat that is in the earth, you know? And I suppose maybe we can talk about this in a little while or so, or yeah.
Thank you, Volker. Kind of sounds like solar and geothermal are quite similar. I mean, it's there, it's constantly there, 365 days of the year, like you said. It's just about how we tap into it, and it can have many uses, but it's about how we tap into it and how we use it going forward for a more sustainable future. So I'll ask the same question to Xiaoyuan. Tell us, what are the real world applications for your research in your renewable energy field? Am I gone like a robot? No, Xiaoyuan, go ahead.
Yeah. Thanks, Nadia.
Xiaoyuan, I'm sorry to say this is one of the issues with Zoom. You're like a robot. So if I just ask you to mute yourself and then just change your microphone very swiftly in between and come back to us. Hopefully you shouldn't be sounding so electronic. The joys of Zoom.
Is it okay?
Perfect.
Right now?
Great. Thank you so much. Go on ahead.
For the application of renewable fuels, I'd like to talk about the biofuels. Biofuels are one of the most important renewable fuels applied in the real world. Bioethanol is an alcohol made by fermentation from a biomass. Ethanol can replace gasoline as a fuel for vehicles, but it is usually used as a gasoline additive to increase octane number or reduce vehicle emissions. And bioethanol is widely used in the United States and in Brazil. And besides these bioalcohols, also, we know that the biodiesel is produced from plant oils or animal fats, and it is the most common biofuel in Europe. It can replace diesel, but similarly, it is also usually used as a diesel additive to reduce the levels of particulates, carbon monoxide, or hydrocarbons from diesel-powered vehicles. So my research can help us to better utilize these kind of biofuels. From the combustion chemistry studies, we can predict the combustion properties of these biofuels in combustion engines, such as how long it takes to ignite the fuel, how fast is the flame burning velocity, how much is the heat released and the pollutant formation. This kind of information is very helpful for engine design to achieve a high efficient and clean combustion. Okay.
Thank you, Xiaoyuan. That was really interesting. So basically your research is adding to a world where we can, get into our car with ease, but instead of using petroleum or petrol, we hopefully will be using alternative fuels that you are researching. So thank you very much for that. Okay, so what are the challenges with all of these renewable energies? Like going back to my original question is, why do we not have solar panels plastered to every building? Okay, so I guess perhaps maintaining, Frederick, I'll hand it over to you. Probably the stability of solar cells, the storage of the energy, it's hard. Please speak to us more about the challenges that you face with regards to solar energy and perhaps the relevance to Saudi Arabia as well.
Yeah, sure. So there are actually quite a few issues that we still need to address. So when we talk about silicon solar cells, for example, then the conditions that we experience here in the kingdom, they're actually pretty harsh. Yeah, if you think about the irradiation, the light intensity that we have here in the kingdom, is about more than a factor of 2 more than we would typically find in European countries. Yeah? So this means that there is a lot of energy dumped into the solar cells, which basically heats up the solar cells. I think everybody can imagine if there's so much light striking a solar cell, a solar module, then it heats up. And this can actually be quite significant. Yeah? So you can reach temperatures of about 60 or 70 degrees, so 20 degrees more than the ambient temperature surrounding the solar cell when you put such a solar cell here in the kingdom. Now, the problem of silicon is that with higher temperatures, you actually lose efficiency. And well, I mean, this could to some extent be engineered. So you need to engineer solar cells that actually lose less efficiency when you are at a higher temperature, but they will still lose some efficiency. Other issues are, of course, if you think about the environment that we have here, for example, sand, so contamination with particles. So you put your solar cells here into the desert. There's obviously a lot of sand. Sand over time will cover the solar cells. You have to somehow clean them. You have to get rid of the sand. So how do you do it? There's basically very rarely there's any water around, so you can't really wash the sand away. So you would basically go to mechanical techniques. You would basically use a brush, for example, and this is technology which is already available. But of course, it adds costs to your PV modules and to the renewable energy that is generated. So there are some interesting solutions, yeah, that we also pursue here in the KAUST Solar Center. If you think about a silicon solar cells are very, very efficient in harvesting red light. They are less efficient, though, in harvesting blue light. So you can potentially combine silicon with other technologies, and a very new technology, which is very promising, is so-called perovskite solar cells. So making a solar cell that has one material which absorbs a lot of blue light, the other material which absorbs a lot of red light, this basically reduces the heat which is dumped into the solar cell, and can improve, of course, the performance and lead to less performance loss. Another potential solution is you make your solar cell absorbing light from both sides. Yeah, so not only from the front side, but also from the back side. So any light that is basically scattered from the environment and comes back to the solar cell from the back could also be absorbed and could generate some electricity. And with that, you also reduce the heating of your solar modules. So all those are actually quite promising. Then coming back to a challenge that I think we have with many of the renewable energy generation technologies, storage. Of course, there's 365 days of sunlight in Saudi Arabia, but then, of course, there's no sun during the night. So you would like to have, of course, a continuous supply of electricity. So somehow you need to store the electricity. And what are the storage solutions that we have at the moment? Well, batteries could be an option, but of course, that again adds extra cost to your renewable energy generation. Batteries also have a limited lifetime. They have a limited storage capacity. What else could you do? Well, you could, of course, convert your electricity into solar fuels. You could do electrolysis, for example, of water. But then you generate, for instance, hydrogen. You need to somehow store your hydrogen in order to be able to use it later on. Yeah, this also adds, of course, extra costs. So there is still a lot of challenges, except, I mean, the engineering of the solar models that we do here to some extent in the solar center. Yeah, some other aspects actually that we have to look at before we really can implement renewable energy generation just everywhere.
Thanks, Frederick. Yeah, definitely lots of challenges. But I think at KAUST, we do have many solutions, especially from our dedicated Solar Research Centre, and also our KAUST startups, Mirai Solar, Iris and Nomad. And I never truly kind of thought about it that the heat and the dust would be a factor to solar cells and their performance. So thank you for enlightening us with that. So Volker, then perhaps you could tell us a little bit more about geothermal, because you've mentioned that you may even be getting a geothermal pump in your house in Germany. So they're obviously doing it in other countries around the world. So maybe you can talk to us about the challenges, and then what about Saudi Arabia? Are we doing it here?
Yeah, right, great. So yeah, there's lots to talk about. So first of all, I think, how do we extract? I explained that the Earth is hot. So, but how do we extract the heat from the ground, right? And so you see the little diagram behind me here. Let me see if I can get this going again. So you drill a well, right, and you pump up a medium, maybe mostly hot water to the top. You have heat exchangers at the top, and then the water gets cold again and it goes down back into the ground, right? And the heat you use, the energy that you generate, you use as a renewable energy. So this is the very, very simple, in a nutshell, kind of way of how geothermal energy works. And so it is, of course, best if it's very hot, right? So that's why when most people think geothermal energy, they think Iceland, they think volcanoes in Indonesia and Philippines and so forth, So that is really good that you have the heat close to the surface, where magma or volcanoes bring the heat to the surface. Because then you don't need to drill these wells very deep, right? They're just very shallow. You can get to great heat, and drilling wells is very expensive. So that way you make it a lot cheaper, and you get very hot water very easily. Now, if we look at Saudi Arabia, don't necessarily think about volcanoes in Saudi Arabia. There are actually some areas where there's some active volcanism, but not close to the urban centers. So, you know, the temperatures when we go down here in Saudi Arabia are just not that hot, even though they still increase by about 30 degrees per kilometer, right? So you can say 30 degrees per kilometer. I go drill a hole 3 kilometers, no problem, same as in the oil fields. And I have 90 degrees water. Well, would that be enough? Wouldn't it be cool if we could drill a hole, you know, 3 kilometers, get the water out, this blue stuff there in the diagram, and utilize it, you know? It's a low temperature application. It's not possible to make electricity directly out of this, right? But here in Saudi Arabia, you know, about 2/3 of the energy that is being consumed in the summertime, at least, is consumed for air conditioning and for desalinating water. So, you know, the everyday drinking water that we're utilizing, and there's been some very groundbreaking research here at KAUST, where they in the desalination center, where they kind of matured some technology to extract a lot of energy out of low temperature waters. So like if you have 100 degrees, it's really way enough to already start desalination and to do cooling, to do air conditioning with this, right? So so this is you know something that I learned when I came to KAUST, and then you can put this very neatly together, these various technologies, and you can come up with applications to utilize geothermal energy in Arabia, there where we need it most, you know, and that is cooling and water, because without air conditioning and water, we can't live in Arabia. We need that. Now, Frederick brought in a very interesting point, and that is you need to store energy, you know. So if Frederick makes and his fellow scientists, they make solar energy, they want to perhaps store the energy for the night in batteries. So some of the water down there, you know, that blue stuff, contains a lot of lithium. So if we pump up the water, we could actually extract lithium from it to make batteries, right? So that would be one way. Another way is you could inject, if you use solar heat, you know, to make very hot water. You can also put this water into the ground and store it there for a while, right? And so there's a lot of very variable technologies that kind of come together, and that we, you know, can combine to harvest renewable energy. And geothermal is, you know, is in a very elegant way for extracting heat that is there all the time, and perhaps also to store some energy intermittently until we can we want to utilize it. So, you know, but that is all very, very easy. So the you know, easily thought to. But then comes the little problems of applications, like Frederick already referred to. You know, this stuff falls apart if it's too hot or so. So our big problem is, how do we drill these holes? You know, how do we make it cheap? Because if you drill a hole to 3 kilometers depth, it will cost you perhaps $10 million, right? That's a lot of money to sink into the ground. Can we do it for $1 million? So that's one way of doing. Where do I find the layers that have the water? So we don't, you know, it's not so easy to predict, right? So these are techniques that are being used in part already in the oil industry when they look for oil fields and oil reservoirs. So these are technologies that where the knowledge that is in Saudi Arabia already on the subsurface, and how to illuminate the subsurface can be utilized to mature geothermal energy for a much wider use than where it is right now.
Excellent. Thank you, Volker. Were you going to say something else?
No,
Okay.
we could talk on for another hour if you want
Yeah,
me to.
I think we could. We most definitely could. No, it sounds excellent. And I guess, as you said, we could leverage on the skill set that Saudi Arabia already have for drilling oil and gas in order to drill for geothermal energy. And perhaps one of the reasons why we aren't there yet, or we're not utilizing geothermal energy just yet, is because we have been relying so heavily on fossil fuels. But now we've signed the Paris Agreement. We in Saudi Arabia are going to reduce our CO2 emissions by 2030, along with another 182 signatories, I believe. So there really is a need for this. So thank you very much. Yes, Volker, go on ahead.
Let me bring this in, we're sitting in a cafe, right, and having a coffee. So this is it's just right, and you mentioned it. That CO2 that we're producing. One of the way to get rid of it, and a lot of people are working on this as well, is to pump it down in the ground here, right? To pump it in the ground to sequester the CO2. Well, actually, if it turns out that if you sequester the CO2 and you put it in the ground, you can actually produce it again, over here, there, in your hot, when it has heated up underground, when you put it down there, it's cold, and then it heats up from the earth, and then you can reuse it to make energy. And that's actually even better and more efficient than using water. So then it has become circular economy. Yeah? So.
Excellent. Definitely contributing to a circular carbon economy, reducing and then reusing CO2. Thank you, Volker. Okay, Xiaoyuan, I'm going to ask you the same. What challenges do you face, I guess, with your alternative fuels? Your topic is so different from Frederick and Volker, so please go ahead, tell us everything.
Okay, thanks, Nadia. Actually, it seems not possible to produce biofuels from a biomass in Saudi because Saudi is lack of biomass sources. But biofuels can also be produced from algae. It is abundant in Saudi. Algae is the third generation biofuels. It can grow very fast and does not rely on the feedstocks.
So sorry, algae from the sea, algae from the water.
Yes, you're right.
Very good. Go on ahead.
It can be converted to biodiesel. However, we also need to face some challenges because one of them is the integration of various conversion technologies in a complete algae biorefinery operation. It is very difficult. So producing biodiesel from algae at industry scale is a challenge. It is a great challenge. On the other hand, I'd like to talk about ammonia. Frederick also mentioned the storage of hydrogen. We know that storage of hydrogen is difficult, and also transportation of hydrogen. But we can convert hydrogen to ammonia. Ammonia is an attractive hydrogen energy carrier and also a promising fuel. Because we know that ammonia can be directly produced from combining hydrogen and nitrogen separated from the air. Let me introduce two words. One is blue ammonia. It is from the conversion of hydrocarbons to hydrogen and then to ammonia, as well as capture the associated carbon dioxide emissions to achieve a circular carbon economy. Recent news from Saudi Aramco says that they produce blue ammonia and shipped it from Saudi to Japan. This is a very long distance transport, actually. In Japan, about 10% power can be generated by the blue ammonia. The other word is blue ammonia. The other word is green ammonia. It is not like blue ammonia, which sources are still from fossil fuels. Green ammonia is produced from renewable hydrogen and nitrogen. Saudi Arabia will build the world's largest green hydrogen and ammonia plant, and they will convert green hydrogen to green ammonia and transport ammonia all around the world. In this project, hydrogen will be obtained from water electrolysis through wind or solar energy. I'd like to talk about the utilization of ammonia as a fuel. Actually, there are several challenges because this fuel has a very low flammability and a high NOx emission, and also low radiation intensity. Compared with the traditional hydrocarbon fuels, the heat of combustion of ammonia is only 40%, and the maximum burning velocity of ammonia flame is only 20%. These facts said that ammonia is it's not easy to ignite, and it's not a very stable fuel for combustion. So we had to face these challenges and to overcome these drawbacks. That's all. Thank you.
Thank you, Xiaoyuan. And then I can only imagine as well that the storage of blue ammonia is not quite easy compared to our usual petroleum, or that we would use the petrol in the car as well. But hopefully, with the help of your research, we will be hopping into cars run by blue ammonia in about 10, 20 years' time.
Perhaps
Hopefully.
Ammonia is not a very safe fuel for car transportation, but for ship, it's okay. We can use a ship for transport ammonia, or as a hydrogen energy carrier to transport hydrogen or transport ammonia. By shipment is a very good way. But for road transportation, I think perhaps there is a long way to do because it is not quite safe. But a good thing is it has a strong smell. If there is a leakage, you can smell it.
Thank you for educating us. Brilliant. Okay, so just before we close, I want to take some questions from the audience. And this really nice question came in from students from the Young Learners Development Program that was developed by Social Responsibility, I guess, at KAUST. They have asked, will the ideal Saudi city in about 15 years be a mixture of different renewable energies, so geothermal, solar, and alternative fuels, perhaps even wind, or will it rely mainly on solar energy? What do you guys think?
Well, maybe I can start.
Please, Frederick.
Yeah, okay, thank you, Nadia. So, well, I think you would always go for a mix of renewable energy generation. Yeah, it's like you don't want to put all eggs in one basket, so to say. Yeah, so it's better to use different technologies. Yeah, and but if you look at the Vision 2030 in the kingdom, it's actually also a mix of technologies. It's a mix of solar, it's wind, there's geothermal there as well. Because simply, yeah, you don't want to rely too much on just one technology. And well, I mean, there's also always issues with one technology, as we have explained now here in the Sci-Café. So I guess my answer would be that there will always be a mix of renewable energy generation technologies. But maybe Volker has more to say, or other ideas.
Excellent, thank you, Frederick. Volker.
Yeah, I think it is very, very likely that the renewable energy will always come as a mix, right? So first of all, it is definitely true that for a very long time we will have to rely also on fossil energy sources, to drive our transition into renewable energy. Right, so we should never forget this, and we shouldn't sound too optimistic. However, there are so many new technologies emerging, and none of them will be the kind of golden ones that does the trick for everything. It will be a combination, and I hope people who are listening today found out that these different renewable energies are actually interfingering quite well, and you can overcome the problem of one with the application of the other, and that is really the opportunity as well to work here in an environment here at KAUST, where you have all the various researchers and the various initiatives coming in to combine this, to listen and to learn and to get new ideas, and that way I think we will drive this forward. And so I perhaps as last thought, there's these big giga projects that are ongoing in Saudi, like NEOM and the Red Sea development, and all of these projects are relying on renewable energy anyway, and they're all looking at mixtures of renewable energies. So I think the answer will be a resounding yes, it will be a mixture.
Brilliant, thank
or
you.
that would be my guess anyway.
I think it's fair to say we're not going to be moving away from fossil fuels anytime soon. I mean, we make plastic from fossil fuels as well. We will still need that, and for sure it perhaps in the future is most definitely going to be a hybrid system. So another question that came in from the audience is, how are integrating your technology at KAUST? Frederick, can I get you to start that off?
Yeah,
Solar
sure.
technology, I'd say
Yeah,
there's
that's
a lot of that being integrated in KAUST.
very good question. Yeah. So, well, I mean, we have already seen a few PV systems here at KAUST. I think there's also the smart home currently being built, which certainly has a PV component for electricity generation. So now back to what we do in the center. Well, we do a lot of research and development. Yeah. So as I've said in the beginning, we try to advance existing technologies. We try to develop new technologies, and of course, these technologies, to some extent, they have to be tested under real conditions. So we have started to use the KAUST NEO test field to actually test the technology, the different types of PV devices that we develop here in the KAUST Solar Center, to see how they perform under real conditions. Speaking again about heating the solar cells, how much does the temperature actually affect the performance, how stable are they under the light conditions, under the light intensity that we have here in the kingdom. So this is one way for us to test the technologies that we develop. We have also, some projects running to scale up technologies. As I've mentioned, when it comes to organic photovoltaics, while they work very, very well on small scale, so you get really good efficiencies, but of course you want to demonstrate these efficiencies also on larger scale. So we run some projects on scaling up technologies. And last but not least, the final step, of course, would be to team up with companies, for example, in the kingdom, partners in the kingdom, to develop together with them products there that could finally enter the market.
Brilliant, thank you. And I think as well, we have like a KAUST smart home, or a test home right here at KAUST as well, where we're testing a lot of the technologies too. So that's fantastic. And I believe KAUST is one of the oldest places in Saudi Arabia where we have like the oldest installation of PV here in the kingdom. So that's fantastic as well. It's 2 megawatts and it's been here for the last 10 years, and we're one of the first places in the kingdom where it's installed. So that's pretty cool. Volker, would you have anything to add to that? How are you integrating your technology at KAUST?
Yeah, so really there's many activities going on, and the smart home was already mentioned. So I'm not directly all that much involved in it, but I know there's a shallow geothermal system going into the ground, and so we'll be checking, does that work? What are the problems and the pitfalls here around, right? There's lots of initiatives within the kingdom with the ministries, the energy ministry, with Aramco, with other universities to drive forward research on geothermal. Where are the best areas for geothermal, etc. in the kingdom, and how can we mature these technologies? But also with the I am also in the petroleum engineering department, right? So we would, of course, and we foresee the usage of fossil energies for quite some time, because we have them in the kingdom. We want to utilize them, but without damaging the environment. So there are, technologies that come in with CO2 sequestration or turning fossil fuels into hydrogen or into ammonia for export or things like this. All of this kind of comes together, and through the research conferences and interactions, we have a wonderful way here to listen and to hear what others are saying, and with that you can get some great ideas. Maybe some of them are pies in the skies, but some of them come true because we're all working on this very hard. Yeah.
Brilliant. Thank you, Volker. No, I think it is definitely fair to say that here at KAUST, this conversation is indeed a snapshot of larger activities that are ongoing at KAUST. And there's a lot of stuff that's going on here where we speak to ministries and those giga projects like NEOM, where we consult. So yes, this conversation is very much a snapshot. So before I end the Sci-Café, is there any last comment that anybody would like to make at all? No, we good. I have been told by our producers that the sound has not been great, so we do apologize to our listeners for that. And I think we'll leave it there. I'll close. And if you do want to learn more about our KAUST research, you can go to discovery.kaust.edu.sa and even sign up for a bi-weekly newsletter. Our newest edition of KAUST Discovery, which is our online magazine, showcases KAUST efforts towards a circular carbon economy. So it is so relevant to this Sci-Café. And you can revisit older Sci-Cafés where we are in front of live audience once upon a time, pre-COVID-19, on YouTube or Facebook. So thank you very much to our listeners, and goodbye. Thank you, guys.